This is our first ER diagram problem, and this is the problem description here, and what I've done is I've gone through it and just highlighted what I think are the important things. We have local employees. Whenever you have people in a database, it's pretty obvious you're going to have, first name, last name, address, city, state, zip code. And in this case, we're going to do it a little differently. We're going to assume here that almost all employees have 3 phone numbers, so we don't really need to create a separate table for phones. We will assume that everybody has at least 2 of these. We know they've got a work phone, and they've got to have 1 or 2 of the other, and that quite a few of them actually have all 3. Okay. A person can coach more than one sport. Okay, so we can't store the sport along with the person. There may be more than one person at the school with the same name. That's telling us we have to use a surrogate key. We can't use the name as a key. And we only need to keep track of 1 person per sport. That would be whoever's in charge of that sport. We don't need to keep track of all of the assistant coaches. Okay. Then we've got some contacts at opposing schools, and we will have 1 contact per sport per school. So at Northwestern, we'd have a football and a baseball contact, and at Dort, we would have another baseball and football contact. Okay, we don't need their address information here. The address we'll use for them will be the school address. So all we really need is the first name, last name, the sport, and their work phone. And it's possible that with them that the contact person can be a contact person for more than 1 sport. Okay. Address information will be the address of the school, so we don't store it with the opponent's information, with the person's information. We don't have an ID number for employees, but it's possible they could have 2 with the same name, so we're going to do a surrogate key for that. And each sport has a single contact person, and that's kind of like it is for us too. We got 1 person per sport. We have opposing schools. We need to keep track of the school name, its address, the city, state, and zip, so we can send the school information via the mail. Need to know how far it is so that we can plan our transportation costs. We're going to use like a 3 or 4 letter abbreviation for the college instead of using a surrogate key. So like NWC for Northwestern College, DW, and so on, BCU, stuff like that. Then we have events. Yeah, that's the whole reason we're doing this database. We have events between our school and these other schools, and each athletic event is assigned a single date and time and location. We're going to combine date and time into a single date-time data type. We're not going to normalize zips. We're always going to use date time for date and time. Now we'll combine them into 1 field. Each athletic event has 1 opponent, and an event basically brings 2 teams together at a given date, time, and location. We need to be able to calculate the cost of transporting the appropriate number of athletes. It'll be determined by how far you're going and how many athletes you have to transport. And we will say that each one of our sports will have a designated travel squad size. And that's just for us. It's not for the opposing schools, because we don't care how much it costs for them to go from one place to another. It's possible for the same opponent to be scheduled for more than 1 event on the same day. So we could play Mount Marty in both men's and women's basketball, so same opponent but 2 different sports. It's also possible for the same team to have more than 1 event in the same day, so a baseball doubleheader. If that's the case, that's still considered 2 events, and but they will be at a different time. So that's how we can distinguish 2 events by playing the same team on the same day in the same sport. The time will be different. Okay. And then the rest of this just talks about the reports that we have to be able to get out of this, and I'm not going to take the time to go over that. What I am going to do is take a look at our functional dependencies that we can get from reading this. So these are the determinants that I came up with, the functional dependencies. Let's see. By the way, I did not come up with these the first time I tried. I made some mistakes the first time, but this is what I think is my final result. So the employee ID, this is easy. Employees are our employees. So we have a first name, last name, job title, address, city, state, zip. And these are home addresses. So we do need a unique one for every employee. And we said everybody was going to have at least 2 phones. Most of them would have 3, so we don't need to put that in a separate table. So this part's fairly straightforward. We have opponent IDs, and this is not the school. This is the contact person at the school. And for them, we don't care about the address information, and we don't need more than 1 phone. So we just have a first name, last name, job title, a work phone, and a school ID that they're associated with, so we know where they're from. School was pretty easy. We have a school name. We have a school address, city, state, zip, and distance. And the school ID here would be like a 3-letter or 4-letter abbreviation like BCU or something like that. And then over on this side, we would have Briarcliff University. Okay. We said that one employee could be in charge of more than 1 sport. So the employee ID will determine multiple sport IDs. And the same thing for our opponents. One opponent ID will determine multiple sport IDs. Okay, we've taken care of the school ID. And then this is an event right here. If we have an opposing school and a sport and a date and a time, those will uniquely determine an event. And the event will have a specific location. Then we have a sport ID, and the only thing that's specifically associated with the sport is the travel squad size, although it is also associated with the employee ID up here. And apparently I have these last 2 in here twice, so I'm just going to get rid of that. We'll delete that. And so it looks like we have a determinant, 2, 3, 4, 5, 6, 7 determinants. And the next thing to do is fix the multi-valued ones, and these 2 are pretty easy because all we have to do is drag the sport ID over on the other side and put nothing on the right side. So this is basically, when we combine those 2, that's going to be an intersection table between employee and sport. And the same thing here. We'll just grab sport ID, drag it over the other side. That's going to be an intersection table between the opponent table and the sport table. Okay. Now I've switched over to a list of my actual entities. I take those functional dependencies that we looked at a minute ago, and we want to convert those into entities or tables with attributes. So we're going to have an employee entity. Its key will be the employee ID. And now we want to make sure that everything in this list here is uniquely determined by the employee ID and the employee ID only. So it will uniquely determine first name, last name, job title, address, city, state, zip, work phone, home phone, and cell phone. And there is nothing in here that depends on any other key, so this one is good. And then we said that employee sport would be an intersection between the employee table and the sport table, which just means taking the employee ID and pulling that in as a foreign key, taking the sport ID, pulling it as a foreign key, and that relates an employee to a sport. Then we have our contacts at another school, and the opponent ID is the key, and as with most people, this is going to be pretty similar. So we've got a key, we've got a first name, last name, job title, work phone, and school ID, so we know which school that they're associated with. And we don't need the rest of these fields up here. Then we need to keep track of which contacts go with which sports. And that's another intersection table. We're just going to take a sport ID from the sport table, and we take the contact ID from this table. And apparently I did not call it the same thing every time. So I called it opponent, and now I'm calling it contact. And then we have sports, and the only thing associated with sport is, besides the key, and we'll do like an abbreviation for that one probably too, is the travel squad size. And this should be underlined. Then we have the school. What we need to keep track of for the school is the school ID, which is that 3 or 4 letter abbreviation, school name, address, city, state, zip, and how far it is. We need to know the address so that we can send them contracts and things like that. We need to know how far it is so we can calculate what our travel costs are going to be. And then the event is determined by school ID. So this is the opponent and the sport, so that narrows it down. But we can play them in one sport more than once, so we also need the date and time. We can't play them twice at the same date and time. So these will make everything unique, and we do need all 3 of them. And what they're going to determine alone is just the location. Okay, so I think that will work for us, and the next step is to take this information and turn it into an ER diagram.